Hey guys, alright, so I'm going to go over number 2. 2 is f of x is equal to 2 over the quantity x minus 5. So I'm going to put it into my calculator. 2 divided by parentheses, the quantity x minus 5, parentheses. Make sure you put that in. If you don't, it's going to come out messed up. I'm going to press graph. It should look something like this. If you don't, it might be because the zoom is messed up. So you can press zoom and then press 6 for standard. Zoom standard. It makes it nice and neat. So it looks something like that. 2 over the quantity x minus 5 looks like this. The way that I want to do this is step by step. I'm going to look for the domain first. The domain is going to be the x values. So the smallest that x can be, I'm going to use these compasses to kind of show us. Do you see that black thick line right underneath the x-axis? That just means that it goes on forever. The calculator isn't that smart. So the smallest number that x can be, going this way, horizontally, is going to be negative infinity. So I can write that in for the domain, negative infinity. And then the biggest that x can be, it goes on forever and ever and ever in this direction. And so that's going to be positive infinity. So I can write that in. Oops, sorry, it's kind of messy. The zeros are where it touches the x-axis. And notice that here, it's a really thick line underneath the x-axis. That means it doesn't touch it at all, because it's not touching the x-axis. It just goes on infinitely forever without touching the x-axis. Same with this way. It never ever touches the x-axis. So for this one, it's going to be none. All right, so now I have my true min and true max. That just means my maximum thing that can have. I'm gonna try to do the true min first. So true min, minimum, means that, well, the smallest that the y value can be is going to be all the way down here. It goes on forever and ever. And so the minimum is going to be negative infinity, and so I can just really write none. And the same thing for the max. It goes up forever and ever and ever, and I just have none. Cool. Now I'm going to do the relative min and max. I don't really have a minimum or maximum just because, well, it really goes to negative infinity and then positive infinity. And so I can just write none. Okay. Now I have the increasing interval. That's when things are increasing. I'm trying to find the domain for when things are increasing. So from here, going left to right, it's decreasing because it's going down. Right, so I don't want that. And going from left to right, it's decreasing also. So there's really nothing that's increasing for here. But I do have something for decreasing, because going from left to right, I have something that goes from up here and then slowly goes down. And so when it goes down, it stops at somewhere here. So I can count, looking at here, 1, 2, 3, 4, 5. And notice that there's like kind of an invisible force field or a line at 5. And it kind of corresponds with this because x cannot be 5. So negative infinity all the way to 5. And the next interval is going to start from near 5 and all the way to infinity. So 5 to infinity. Again, this is the domain of where the interval decreases. So from here, that's 5, all the way to positive infinity. So basically you're looking at it like that. Except you know that this goes on forever, and so it's positive infinity. Cool, next thing. Positive interval. It's where things are, where the function is positive. And so here I can see that this piece is negative because it's below the x-axis. And this piece over here is above the x-axis, so it's positive. And so I want to have this piece of the thing. I want to find a domain of this piece, which I already found out before. And so that's going to be 5, infinity. And then for the negative interval, it's going to be this thing over here, this piece over here, which is negative. And so I have negative infinity all the way to 5. And that's it. All right, see you guys later.